Dr. Joel Cohen, uh, he fell in love with nature when he was with the Peace Corps in Nepal. And so when he came to the United States, he decided to get his PhD in nature, evolutionary genetics and conservation of plant and animal resources, and I assume mushroom resources too, fungi. So he's been active in international research in biological diversity conservation around the world. And then he came back to Maryland, and he's been a wonderful science teacher. And he's a visiting scholar at the Nicholas School of the Environment of Duke University.
Right, so we're going to talk about, hey, where did all the mammals go? And we started off with a number of them. New ones are being discovered all the time, but our numbers are also shrinking recently. So we're going to look into that. And let me just go to the next slide right away. This is what we'd like to cover tonight. Doesn't mean that we're going to make it all the way through. If people have questions, please, I'll stop periodically as we go through the agenda and see what's on your mind. If we don't make it all the way through, we can cover it later at another time. I'm going to start with what is a mammal anyway. I know there's some obvious things we think about, but there's some other things that have come up through evolution that are rather peculiar to being a mammal. And then we'll look at yesterday, today, and tomorrow, kind of our evolutionary picture. From there, we're going to look at a case study, you might say, about the United States and its position on the bison, our largest living native species, and how they had to struggle to be here with us today, largely at the fault of our own hunting. Next, we'll turn it on over to Maryland and look at mammals that have been recorded here, both some that have been lost and also some that are here living. Talk about endangerment, endangered species, and then some ways to help in terms of some of these issues, and try to wrap it up. I'm going to try to get through that by 8:35-ish, let's say. And again, if that doesn't work out, that's fine. I'd rather everybody get involved in the discussion than rush through the presentation. Okay, what is a mammal? Well, we have some rather unique features, and I have a few cartoons thrown in here on the side. The whale one is interesting because how are we ever going to evolve if we keep pushing them back in the ocean? Well, in fact, I don't know how many of you are aware, but the bear ancestral species went back into the water and became whales. And that's one of the reasons we'll look at later. Their fins share a similar structure to our arms. Latest count on our species is 5,700. Divided into 16 orders. We run everywhere from the platypus, which is still an egg-laying species, all the way through up to the orders containing ourselves and the primates and so on. Most of us live on land, and we have the record for being the most successful vertebrate animals that are living today. So we have been able to colonize the earth better than any other group of organisms. And I'm going to talk a little about why that is, something in particular that allows us to do that. And we're now also altering on a global scale by one species more than any other, and that's us. So that's a little bit about kind of what we're about. Now let's look at how some of this got started. I was recently with my wife on a trip to Denver, Colorado, where we were there to see our new granddaughter. And while I was there, I was able to get over to the museum where they had a special show on the new evidence that's coming forward about where mammals came from. And it's a very interesting story because it coincides with the rise and fall of the dinosaurs and the asteroid theory about its impact on Earth. And when Walter Alvarez first came out with his book, I hope you can see that, The Crater of T-Rex and the Crater of Doom, there was a lot of skepticism about whether, in fact, this really happened. And one of the things I thought was so exciting at Denver is they actually had a piece of the rock there where you can see and the blue arrows pointing to it, this trace of iridium that runs through the boundary between these two different geological periods. That trace of iridium is found around the world, which gives you an idea of the magnitude of the impact from the asteroid. And it's a astrological element. And so therefore, it couldn't have come from anything but this type of intersection between a non-terrestrial body and Earth. And this is one of the way that Alvarez's theory eventually came to be accepted in science. Well, what's the importance of all of this for our story? Well, it turns out, as per the scientists at the Denver universities, that our ancestry in terms of mammals go back before the impact of this asteroid. And we'll get a look in a minute about kind of how we looked at that time. Not real flattering, but that's where we got our start. And when that impact came, those tiny animals compared to the dinosaurs were the ones that were able to kind of sneak through the gate. So here we are. I don't know if you can pick out your aunt and uncle there, or your great ancestors or so forth, but these primitive mammals were the ones that actually were able to kind of get through this eye of the needle. And you can see here Stephen Jay Gould's drawing that the dinosaurs are pretty much blocked out. They actually died from starvation, the sauropods, and the carnivores, of course, once their food started dying off, they died as well. The real problem was that the asteroid on its impact caused a cloud of smoke and dust to settle around the Earth and blocked out all photosynthesis. And these fellows had a pretty good appetite. So when we're talking about that, we can kind of measure it in several hundred pounds of food a day that they were consuming. Well, obviously, with the blanket of soot around the atmosphere, photosynthesis wasn't nearly enough to be able to feed that kind of an appetite. And gradually, all of this combined led to the demise of the dinosaurs. That was good for the mammals, though, because you can kind of see them squeaking through here, through this imaginary gate, if you will. And as they began to get through and the planet began to return to a healthy state, they began to diversify. And in Denver, they have a lot of the creatures that came forward from that didn't make it. And on the right side of the picture here, we see more of the ones that were able to make it through and continue to diversify and are still with us today. So the mammal takeover, as is called there, really is almost a victors by default. We kind of won out because the dinosaurs were lost in this tragic, you might say, collision with the asteroid. So that is where we got our start. And it's quite a long time ago. So as I say, now we're up to 5,700 species. So let's begin to look at kind of what we've learned about that. Well, part of our history was not so favorable in terms of becoming this kind of a super species, if you will, in the history of life on Earth. And Dr. Hornaday, who I quote here, this is his book from 1913, "There could be no mistake, hunters spreading urban developments and ladies' fashion trends were systematically diminishing the native wildlife of America. By 1913, all right, Hornaday could identify wilderness areas in North America where already 98% of the large and small game animals, which were mammals, were lost to hunting and natural causes." And you can see those areas here. So Hornaday was able to actually go out to these areas and tracking through very early animal surveys this decline. And he was really the first person to really bring forth kind of a scientific data-driven approach to these kind of exterminations. Well, part of the problem arose from the desire at these times for these type of feathers to be in women's hats. And this really led to the loss of many, many bird species. These are actually ostrich plumes that came from a museum where they declassified them. And Hornaday really got involved in this and actually went and started to show the type of birds that were being lost and whose feathers were being taken. So it was a widespread, a massive industry with centers primarily in New York and London. All right, well, we also started to diversify, and this is one of the themes I want to talk about. But as we started to diversify, all of the mammals became homothermic, which means that we could regulate our body temperature. This was a huge difference or advance over the amphibians and the reptiles, which were our predecessors on Earth. And something very important came out of that. And that was that for the first time, an animal was eating not just for the energy to propel its body, it was eating to stay warm. And so we kind of had a double reason for needing better nutrition from our meals. Consequently, our whole mouth structure started to change, our digestive system started to change, and mammals began to be very good at sapping all this extra nutrition out of its food that before was much more difficult for amphibians and reptiles and the dinosaurs and so forth. So no matter whether we were in the primate group here, or you see the bats and the squirrels, no matter where we were going, in our diversification, we were able to do this very important thing that helped us in our spread across the planet. Because if you can regulate your temperature internally, you can live in environments where before it wasn't possible. All right, well, I'm moving on to another thing we want to look at, and that is that we inherited these homologous structures. And if you've ever kind of looked at a skeletal system or been able to see one in an anatomy class or a doctor's office, you may not have thought about it, but our arm has a certain pattern to it. We have one very large bone, which is the humerus, comes out of our shoulder socket, and that joins into two lower arm bones, the ulna and the radius, which then goes into the carpals. And if you sum that up, I've got a little drawing here. It goes from one very large bone to two to many. So if you look at even back in the dinosaur days, that was still continuing. Here we have the seal, and you can see the one very large bone, the two separate bones, and then the group of bones. So homologous means that it comes from a common ancestor, which implies an evolutionary emergence. So we have that in common as well, but the function is very different. So you see here, even the humpback whale, which you can see hanging in the Museum of Natural History downtown, has that incredibly same pattern, the one very large bone joined by the two, and then the many. But it, of course, became a fin. Our arm relied on the separation of the digits because we're tool makers and so forth. We also see the bat and the bird, which of course would be winged, and the lizard that has that same separation. So we share this tremendous homology, not only in our physical structure, but also in types of things like metabolic things that I mentioned. So that's a little bit about how we got our start, where we're evolving and how we're evolving. And this then looks at it from a little bit of a genetic perspective. You can see at the very bottom of this slide, the chicken and so forth, the zebrafish, definitely not mammals, okay? We start above that, and you can see that we then have a genetic relationship as well, going through these 16 orders and 5,700 species. So what happens to a cheetah, which we'll look at in a little bit, also has direct bearing on the rest of the mammalian system and ultimately to us in terms of what we learn from that because of similarities that we share. Let me stop there and see if there's any questions that have come up. I guess you can shout out if you're brave enough, or send a note to Mark or Lily. If we're all good, I'll proceed. All right, well, things got off to a great start, and the cheetah, of course, is our fastest mammal. But it ran into a difficulty as
I have one question, Joe.
fantastic.
I just got an email from Melina. She's going to have our crustacean guy, Emilio, come out and try to restore a natural wildlife corridor near where she lives. And she's inviting you to join us and look for endangered mammals. So just let us know a date and we'll do it. I see Melina's going to say something.
Mark, once again, you've expanded on a project to make it larger and better. Thank you for inviting us.
4392.
Okay. Let's go back.
I guess that's more of a comment than a question, but fantastic.
The question is, will you join us?
719.
She's going to send
Be
out an
glad
email
to.
and just let us know when you can come.
Okay, any other points? All right, well, let's go into the cheetah story then, keeping on time here. So what happened? Things got off to a great start, and then what happened? Well, the cheetah's habitat began to shrink. Why did it shrink? Because of a rapid urbanization, conversion of the grasslands to farming areas and so forth. And you may not think, well, okay, so the range is decreasing, but what does it have to do genetically? Well, that's what we're going to look at. And if things go well, I have a short National Geographic clip here, and we'll see if we're lucky enough that technology is working for us.
In the last 100 years, the human population in Africa has grown very quickly. This growth has encroached on wildlife habitat and forced cheetahs out of 91% of their historic range. Cheetah populations are nearly extinct in their Asian range, except for a small population in Iran. And so today, fewer than 7,500 cheetahs remain in the wild. Conservation biologist Vincent van der Mera is one of the scientists working to help maintain cheetah populations by relocating them to increase their chances of producing strong, healthy offspring.
I'm a cheetah matchmaker. I actively manage a stud book for cheetah in 53 different reserves across the country. So I effectively identify which cheetah are related to each other to swap individuals between these reserves to prevent inbreeding.
Inbreeding is when offspring results from the mating of closely related animals. And for the cheetah, inbreeding can lead to less robust cheetah populations, driving the vulnerable cats closer to extinction. So Vincent's team is moving a male cheetah to keep him from mating with a close relative.
We prefer natural gene flow, but the landscape has been transformed by human activities. It's no longer possible for cheetah to traverse the landscape. The vet's got his dart gun ready and he's going to fire away. It's then that you realize things are either going to go well now or they're going to go pear-shaped.
While certainly startling, the tranquilizer doesn't hurt the cheetah, but temporarily puts it to sleep, allowing for various tests, including a DNA swab of the cheetah's mouth.
It takes them a good 5 minutes to go down, and in that period, they can cover a fair amount of distance. It's often quite tricky to locate it, especially if there's a thick bush. But once we've immobilized a cheetah, we've got about 40 minutes to do various amounts of work to obtain genetic material from them. We then put the animals into relocation crates, specially designed to prevent the cheetah hopping around too much. I must be honest, I still go through bouts of nervousness. We've learned that it's not easy to relocate wildlife. They're very stressed, we need to move.
During the 12-hour drive to a private game reserve, the cheetah is at risk from overheating, pneumonia, and stress.
We prefer to release in daylight so that animal doesn't run into the fence lines and fence posts. During emergencies, we sometimes have to make the hard call of releasing at night.
To calm the cheetah, the team releases him into a temporary enclosure known as a boma.
If he starts running into the sides of the boma, then we'll be left no option but to immobilize him again. It will not be ideal, but the last thing we want to do is lose this cat.
Soon, he will be released into the protected reserve, free to repopulate the species with his desirable genes.
Nice and relaxed. The very best moment for me in this job is when you get that phone call from the reserve manager saying, Vincent, we've got 4 new cubs that were born to the cheetah that you brought in here 6 months ago. That is what really brings joy to my heart.
Oh, just 1 second. All right, so we're back, and this is what's known as a genetic bottleneck. And what happens is that it forces inbreeding to occur in a normally outbreeding species. And it's a product, as I was mentioning, of reduction of habitat. So another thing that we'll talk about that's so important to mammals is the ability to move. And not only is that important in mammals, but in many species where we run the risk of creating these genetic bottlenecks because we're not expanding the population of mating spouses. So very serious problem. Now we want to turn to kind of the bison as this case study. So in 1941, the bison population fell from 40 million animals to a few thousand. Why was that? So you have to think about, well, 1940s, okay, it was after the Great Depression, before the war. But before that, the Native Americans depended on this for their economic and spiritual way of life. At that time, we were at what might be called an undeclared war with many of the Indian tribes. And the US government, I have this highlighted here, actually encouraged more wide-scale dissemination of the bison to end this war. So millions more bison were killed and slaughtered just as a way to prevent the Indian tribes from being able to survive in the normal way that they would have. Well, in 1905, much thanks to William Hornaday again and Teddy Roosevelt, a Bison Society was formed, and they began to reverse this trend. Otherwise, we would have been guilty of creating an extinction event in our country of our only large Native American mammal. Luckily, they do survive today. And this is a museum painting by paleo artist J. Matterness. And one thing that's interesting here in the background of the bison are people hunting down a megatherium. And this is the way that many of the large mammals were lost to us. So the megatherium and many others were lost during hunting at that time. The ones that survived were often went the way of the bison later on as time went on. And this is his artistic work here. Well, this is a Currier and Ives painting. And this is one that came from a book I purchased of the original copies of this. So this is what the original Currier and Ives would look like. And it was a one of their most popular prints because Currier and Ives, they were kind of like the Reader's Digest of the time. and getting things out to as wide a part of the public as they could, had never seen anything like this. But this is the way the Americans were encouraged to go out and to kill the buffalo. So it's from the 1942 book, and it's illustrating how this was actually done by the white settlers. So not a very nice chapter in our history, and almost one that was almost irreversible. Well, where can you see the bison nowadays? So on a prior trip to Denver to visit our son and daughter-in-law, we were able to go out and actually see these. Those aren't the bison there on your screen now. Those are the little prairie dogs. They're out there too. But you can see that according to Stuart Pym, who is the person I'm working with, human population growth and our increasing per capita consumption is the reason why, well, two of the reasons we're losing so many species. This is the bison area there. And this gets to my point of how much space is needed in order for mammals to really be able to survive and avoid the bottleneck that the cheetahs were going through. And this grazing ecosystem that they live on there in Colorado, as you can see, is one of the most endangered terrestrial habitats that we have around the world. You saw the same thing happening with the cheetahs. That's because they need this tremendous amount of land to roam, consuming their food and for energy and heat and so forth, but also for mating and to have populations that are viable and so on. As that land is shrinking, it's not just the cheetahs and the bisons and so forth. It's mammal after mammal that's feeling that effect. All right, so that's where we'll kind of leave the mammal story. The last slide I had, though, was kind of bringing it back home. And I know there's a large mammal bison working group. And one of the things I wanted to mention is SB Farms, which is kind of towards the Bay Area. They actually run an all natural bison ranch. And of course, they're farming the bison there for slaughter so that they can allow that industry to flourish once again in America. So they're able to raise the bison, and they offer burgers and so on and so forth down there. And I haven't actually seen it. I just pulled this up and looking for the reality of the bison growth in Maryland. And it was one of the few real operating situations I could come across. And they're able to do it on a wide range that they have there. So it's a real area where they're feeding from the pasture. Okay, well, that is the bison in Maryland. So there we've got a case where this farm is trying to expand the range so that they're able to live and breed and raise the way that they were used to. Well, let's turn to Maryland's mammals now and take a look at kind of where we are with things. And I have it from a number of different perspectives. I kind of thought about these slides a lot. So this would be a developer's perspective. What if he or she were explaining Maryland, would they be looking at? Well, as you can see, over since 73, the amount of development in acres being converted to development rising sharply. Agriculture is falling and forest is falling. So you notice as they look at their strategic assets for Maryland, we don't see too much about natural places, about parks, reserves, and that type of thing. We see more things from the developer's perspective that would ultimately take away from that. And I think it's worth keeping this in mind, just so that we understand the nature of the people that are involved in all of these discussions. That's from the Maryland Economic Development Association. It's nothing I made up. I just kind of put the materials together there. All right, so that certainly does not look like a trend that would be supportive of this type of recognition, let us say, for this expansion of land availability for the sake of wildlife. Well, what about from the mammals' perspective? All right, well, we can see here that we do have an area of species richness, a lot about that in the western part of the state. And over here, we can see that from the mammals point of view, this is getting pretty congested out in here. And that's one of the reasons I'm so interested in the possibility of the C&O Canal offering this 184-mile passageway right through all of this. It's pretty remarkable. Something that started in the so long ago can have this alternative future for itself. Well, the two, as you can see, kind of are overlaying one another, and they're definitely going to have areas of friction because of that. And that is one of the reasons that the corridor work and the neighborhood corridor work that other groups are doing and so forth all has such tremendous value. All right, so that would be the mammal's perspective, not kind of going the way the mammal would want to see that. All right, so Mark mentioned in his earlier introduction that a number of the larger mammals have been lost in Maryland. The gray wolf was around the mid-1800s. We have the elk, the mountain lion, the hare, the marten, and the harvest mouse. It's just those examples. But we also have a lot of groups of mammals that are still living here. Not always easy to see, though. And we were talking about this a little before we started, but if you want to really see them very easily, go to Denver. Go to Denver. That's what I can tell you. And I'm sure my son would be happy to run a tour circuit out there for you when you're there. All right, so we've got a good population, not always easy to see, but definitely a lot of pictures. You can certainly talk to Sue about seeing these as well. Well, what does it look like then in terms of kind of how does Maryland look in relation to the rest of the country? Well, we can see that in terms of number of species, this is a combination of vertebrate diversity and mammal diversity. We're kind of on the lower end, but still pretty respectable. Endemic species are the ones that have been born and raised here, you might say. Bit lower on that, but not atypical for what we see in the northern part of the country. Of course, in the south, much more endemism. And then species at risk, though. We could be doing better than that. So this comes from a 2000 publication, Our Precious Heritage, the Status of U.S. Biodiversity, kind of lets us get a picture of where we are in mammalhood, you might say, compared to the other states in the country. All right, well, let's take a look then at what the endangered species side of all this looks like. And you can see here that humanity has managed to wipe out 60% of the mammals, birds, fish, and reptiles since the year 1970, leading the world's foremost experts to warn of this annihilation, which I know you all are familiar about. Well, let's look at it then in terms of our mammals. All right, so here we've got from 2007 going out to 2019. The mammals are at the bottom of this scale, and you can see a marginal kind of increase in that, but overall increase going up considerably over each period of time that this was done statistically measured. So the mammals are losing out, as are the other species. And it looks like fish are losing out the most here. I haven't studied it in great detail, but certainly not a good story.
Can I make a comment, Joe?
Yes, sir, please.
To go back to the previous slide.
Yes, I hope I can.
The International Union for the Conservation of Nature is an excellent way to find out about endangered species that for some reason are not yet on our federal or state list. And that's what we found in the mushroom talk. There were 4 species of mushrooms that are on the international list, several in Maryland that are not on the federal or state list yet.
Right.
So I want everybody to know that as you work with every group of animals you're working with, or plants or fungi, don't forget the international list. Okay, I just want to make that point.
Yeah, the red list from the IUCN will have that. All right, well, our human footprint then continues to be very, very dangerous. And that brings us to the point of movement. And I love this song from Madagascar here. Well, why is this movement so important? I've been harping on it here. Well, it turns out very important ecological functions. It transports nutrients and seeds between many of these different areas, which is essential for repopulating forests and so on. Also, it brings different species together. So we have a commingling effect like you see naturally on the African savanna. It allows for interactions of these food webs that would otherwise not occur. And if mammals move less, that alters all of these things. And as you can see, we're using 50 to 70% of the Earth's land now. So these kind of hidden values of all this movement are being lost. And of course, as they're lost, that lowers the value of the ecosystems and the ecological services that these areas can provide. So it turns out this movement is not just something to take for granted. It's actually a very important part of the corridors and other things that people are trying to do to help rebuild these channels. All right, well, extinction rates before and after us. So you can see here for mammals, species before 1900, 2,900, to present 2,500, extinctions 36 rising to 43, and so forth. This is also from Stuart Pimm's survey of global biodiversity and rates of extinction. Well, what I didn't want to just end on all that. I wanted to end on some things that could help with some of these things: corridors, revenue-based stamps, and response capacity. I'm looking at about 10 minutes, so if there aren't questions, I'll try to hit these. Wildlife corridors, national and local. Well, thanks to working with Lynn Davidson, she's been able to kind of pull out from the herpetology work the quadrants that would relate most closely to the C&O Canal for the full distance traveled. And we're able to look then at species richness as we kind of move through that. And this is something we're just beginning to look at, but it's very exciting, and we'll be able to hopefully find areas or centers of diversity where these different species exist. And the mammals we haven't looked at yet. We're starting with the work from the Herp Atlas as a way to get into that. But certainly this is something that can be done, and keeping these records and data be very important in terms of that. This is a list of the mammals from not my work, but from Napier's book. See if I can get this centered. Potomac Pathway. All right, and so there's quite a slew of them out there, a total of 45 that have been typed out at one time or another, ending in the year 2011. So there's a lot of work ahead of us, but beginning to compile this and recording it and so forth for corridors will be very important. Second thing I wanted to mention are revenue stamps. And this is something that most people aren't familiar with, but Maryland actually has a whole series of these for the black bear. And they're very interesting because when you buy these stamps, the money actually can help repay farmers whose fields or crops have been damaged. They can help instill breeding. I don't know if you can see it well. These are two bear cubs up in a tree here. And they have a number of things where this funding is going. Vermont has a habitat stamp that you can also buy into, and it helps protect the habitat areas for the wild animals in Vermont and so forth. Almost every state now is doing this. I bought into a number of them just to begin collecting and looking at how they're carrying this out. And the federal government has the Save the Vanishing Species stamp. And this one is quite remarkable. This is a sheet of the stamps here. when you buy into these, that money is actually going to multinational funds all around the world, not just domestic. And I've listed just two of the ones here. The one Africa, and then the Great Ape Conservation Fund. So by simply buying these stamps, about a quarter of the price of that stamp goes into these conservation funds. So the world is responding. It may be slow in comparison to the rate at which we've been urbanizing, but the world is responding. The one that I'm most concerned with, and Mark touched on it about the book I'm working on with Sue for adolescents, is getting our response intervals faster, because we learn about the threats to these animals. This is some work I did earlier, and you can see that between the time where we learn about the threat, by the time an action is finalized, a great many years can go by. And I think if we really begin to work and target the younger generations coming, they can become more aware of this sooner, know where to go faster, and help make our turnaround time become a lot quicker. So I'm very devoted to kind of wanting to see more of this type of education in schools so that people can become sensitized to it and know how to react and respond faster than we have. And all right, tail end of the talk here. Well, marvelous mammals. The baleen whales are the biggest animal that's ever lived. No other land animal as fast as the cheetah. Animals have, the mammals have this behavioral versatility and inventiveness that really isn't seen elsewhere. We have an underlying intelligence, at least part of the time we do. And most variable form of the vertebrates, even though we've got all these homologies, those homologies have kind of spread into the water, into the air, bats flying with sonar, and so forth. We are the kingpins of the Cenozoic geological age and setting the tone for our ecosystem. So a lot going on in the mammals. My last slide is any questions out there. And Mark, I have finished by 8:30.
This is for, my first question is for everybody in this room. Can I go to the local post office when I need more stamps and ask for these particular stamps?
Yes, you can.
And how do I ask for it? What do I call them?
Endangered species.
Okay. Everybody got that? Next time you buy stamps, get the endangered species stamp. Okay. And I had another question, and then I want to go around the room. Speaking of Hurlock, Maryland, where they have the bison there, were they introduced or reintroduced? In other words, is bison native to Maryland?
Bison really did not like the East Coast too much. So they moved west very early on. So I would say they've been introduced.
Okay, not reintroduced. All right.